So hello everyone, I guess we are live now. So sorry for the late night live session. Actually it's early morning now, but I haven't slept yet. Okay, so let me fix my voice. I think it's fine now. Let me just check if the live session has started or not. Okay, so here we are. So sorry for the late night live session. Cool, I think we are there. I just need to capture the display. Okay, so here we are. I guess this is cool now. What I love about today's problem is that it is really very short, unlike yesterday's problem. So what are we going to do? This will be a real fun session, guys. Okay. So those those who are new to this channel, like they should know that this is a channel where we live. This is a live attempt of this problem. I haven't solved this problem before. This is my first attempt. You see, there is nothing. But I know data structure and algorithms to some extent. So this will be an approach building process. There are three steps. First step is to read the problem. Most important step. Understand what is required and what is given to us. Then we have the second step, which is where we think about the solutions from the worst to the best, depending on the constraints which we have been given. The third step is actually coding it, the solution which we framed. So the algorithm is common. Basically, it's just a text form of how we solve a problem. The code is just a language translation of it. So whether I use C++ or Python or JavaScript, it doesn't matter. All the languages have their some complexities and some workarounds are there for everything. But the core idea should be clear to you, which is how we solve this problem, right? So I have taken a screenshot of this problem before this session, but I haven't read it yet. Without any further ado, I would like to jump into the problem and solve it. Let's see if we solve it or not. Okay, so this is the problem which says number of sub-arrays with odd sum. Number of sub-arrays with odd sum. Cool. What does it mean? Sub-arrays. What is sub-arrays at the first place? According to me, sub-arrays is basically if you have given some array. Sub-array can be any segment of it. Any. Right? The number of sub-arrays which has odd sum, right? The sum of sub-arrays is odd. So we need number of sum of sub-arrays right? So we are given an array of integers ARR. I think this is a very simple problem. We are given the ARR array which has integers here. We have to return the number of sub-arrays with an odd sum. Answer can be very large. So return it modulo this value. Cool. Okay, so we have to return number of sub-arrays. This number could be very large. I think, yeah, probably in the order of n square. Like how many sub-arrays we can create is actually n square for an array of length n. This is the example which we are given to us 135, and there are four such sub-arrays they have figured out. The first one is this 1 itself, 3 itself, 5 itself. Then we have 3, 5. Okay, so this is all sub-arrays which are possible out of this. Since this number is 3, this will be in the magnitude of n square, but the exact number will be different. So here we get 3, 3, 6 sub-arrays which are possible. It is basically the summation of 3C1 plus 3C2 plus, yeah, 3C3 and stuff like that. But we should be right. I think this is a summation of this, which is actually good. It's cool. But for the array of length, no, this is not possible. Sorry, guys. This is a misleading thing because that is for all the subsequences which can be there. Yeah, so for generating the number of sub-arrays, it's basically for one size we have n contiguous blocks, just three. We have exactly n minus 1. So it's a summation like this. So it's actually a n into n plus 1 by 2 order, which is ultimately n square. For 3, it will be 3 into 4 by 2. So we get 6. So see 1, 2, 3, 4, 5, 6, 7, 6. So they calculated it and they calculated the sum of it, right? And here we get the answer is the number is 4. So this can go up to order n square. And since n is of the order 10 to the power 5, it could go up to 10 to the power 10, which is large, so we have to use a modulo, which is 1 in increase. The values are, however, in this range. The sum of values could go as low as like 100 into 10 to the power 5, which is 20%, which is well within the int data structure. Cool, I think we are good with this thing. Now what I need else is the logic. So the first and foremost logic which comes to everyone's mind, this is the second step. Now you understood the problem. Second step is coming up with the problem. So first step will see someone will say like generate all sub arrays, sum them and count. Right. This is somewhat uh, order n square, which will not pass. Use some other color, which will not pass. Right. This is a third one, so I'll say T1. The third two is something like this. The third two says that yeah, so thought 2 is this, that I don't need to generate all the arrays. What I can do here is basically for the length one, what I can do is I can maintain this some variable here, and I just move in this path. Cool. That will be good. Like we maintain a variable which sounds people in this way, and like remove people which are behind, and it goes like this. For example, for the size one, we'll be doing like something like this. We'll be storing 2. In the next step, we will be storing 4 into it. And we'll be removing since the size is 1 only, right? So we are here only. So we need to get rid of this one. So this one is got rid. We come up with 6 here. Oh, sorry, minus 2 is there. So we come up with 4 here. Then we move to 5 similarly. So for size 1, we get 2, 4, and 5. We check which ones are odd and we just like add it. Then we will do the same thing for size equals to 2, where we maintain 2 with 2 pass variables, which basically is 0 to 6. And as we move ahead, we add the incoming element and we subtract the previous element. So doing this, we can generate all the subarrays of size 2. So again, like this, these things are itself. This approach is also, this is thought 2. This is also ordering square, rejected in the first place. Now one thing which comes to my mind is this, that since the answer itself is too large, so if we count these guys one by one, you see, we're counting them one by one. So it will never count one by one, it will definitely be 10 to the power 10th order, which is not good for the time complexity. So what I decided, like what I thought of is that we need to do some sort of computations. Some formulas can be used, right? Let me think how we can jump in. So these questions where we have some problems like even or odd, we have this thumb rule that even plus even is always even. This is the only case where we get even, and this case. Otherwise, we will get an odd. So these are two cases where we get the even. Cool. So what we have in any array, what will we have? So we have some numbers like 2, 3, 5, 6, 8, 7. Right? So this 2, I have to really decide about which. Right, so I have to decide like which elements it will. So we will go in this direction for this 2. 2 itself is nothing. When it meets an odd guy, I'm talking about all the arrays which starts from, which include 2. When it meets an odd guy, it is getting turned on. Basically, it is um, getting odd, right? So this is an acceptable answer. When it goes one step beyond, there are 2 odds, so there was only 1 odd. This itself is an even case. Now there are 2 odds, then 5, 3, 8 to 10 is even. So 2 odds there was no improvement. Then we got 2 odds only. So here also there is no even number. Here also there is no even number because of 2 odds. But here at this step we got 3 odds. So here we got like this answer and this answer. So you see what we need actually for this 2. For this 2, I just need this information that how many odds are there if we go this way. After this, how many odds are there? So I'll probably say there are 2, 3 odds. So it means itself is even. And if there are 3 odds after this, it means that when we move from 2 in this direction, for the first odd and the third odd. So, so these two guys. For 3, we got like 1 and 3. If they would have 10 odds, then this is the case. So like 1, 2, 3, 4, 5, 6, positive to 10 odds. So this will result, this will also result, this will not result actually. There are 2 odds. This will result, not result, result, and all the way up to like this. So in 4 you see there is an even pair. So if this number is 4, we get 2. If this number is 3, in that case also we get 2. So this is basically this number which I count number of odds. So for 2 the answer is basically number of odds divided by 2 plus 1 if this guy is odd itself. For even guys it is the case. Now let's say we talk about this 3. 3, 5, 6, 8, 7, right? So this individually is a odd guy. So for odds, we just add 1 to the answer. Now, as we go like this, 3 to 5. Now there are 2 odds, again 2 odds, again 2 odds, and again 7, we got 3 odds. So here we got like 1 answer, because after this there is only 1 odd, so we got 1 answer. So I think for this it works similar way. Just for the odd sake, we have to add a plus one, and we have to contain this count as well. Whatever number of odds which are there, since there is 2 odd, so what we do in this case is basically there are 2 odds, right? And since this guy is an odd itself, so it is actually um, there are 2 odds here, right? So here also, here we can just apply the same logic, 2 by 2, which is 1. Why the same logic is working here? Because if we had one more odd here, 3, and then we had 4 odds, that will not probably lead to result. If we had one more odds, which is basically 3 odds, in that case, this guy will say, like if there are 3 odds in that way, this guy will say 2 times. 2 odds, then in that case, this is even, this will become odd, and this will become even. This is like the fourth one. Okay, let me write it in a better way than everyone can get it. So what I'm saying is, let's say this is the high, 2, 3, 5, 6, 8, 7, 8. So for even guys, number of odds beyond it, let's say it is x, right? And what does that mean? It means that as we move, we start with first odd all the way up to x odd, right? And at every this step, it will be a plus 1 to the answer. This will be second, this will be third. So I have to find, technically I have to find from 1 till x number of odd numbers, which is x by 2, x is even, x by 2 plus 1 if x is. Make sense? Now for this guy, I'll use a different color. For odd guy, here this odd guy is itself there, and then for it, there are 2 cases actually. Okay, I think the position also matters, man. Because you see, let's say this is even, then it has no effect. Position also matters because, see, if I tell you this example, where we have 2, 3, 6, 7, 8. For 2, this is one example, good example, where there's only one odd. For 6, there's still one odd. There's one more answer. For 7, now there are 2 odds. This is not an answer. For 8, this is not an answer. There's 2 options. But you see, this reason, this odd, two odd G's in, right? This guy is profitable because yeah, here it will result in an answer. 7 will probably nullify it, but let's say if there's 9, it will start again to some extent. So this approach is not correct entirely because not just number of odd numbers we have in this region, also how many evens are here. That also matters. So if I make a prefix array where we have, if I just store ones here, if the number is odd, in that case, so we add 1 here, this was 0. So now, if I make a prefix sum of this, this will become 1, 1, this will become 2. Now this will also become 2, this will also become 2, this will also become 2, this will also become 3. This will be the weight for this particular guy. So we have to count, this is an answer for this 2. For the all the arrays that start from the array. Let me be more clear on this. I know I'm not making that much sense. So let's see here. This is the 2, right? And let's say we maintain some array where we just stored 1 for the odd and 0 for even. I think this is not a good example. This should be like 0, 0 and 1. Let's make 1 here. Right. For this 2, we check what's next out of it. So we say that obviously 3 will give it a 1 plus guy. This will also give plus 1 guy because the number of odd is 1 only. So if I make a prefix sum of it, it will be like this. 1, 1, 1, 1, 2, 2. Here since this is odd, this is 1. 0. Yes. So what we do is basically we can sum up these. 8 to 0, 0. Let's say we had 9 over here and then we have 8. It was 10 over here. This will be like 1, this will be like 0. So this now again becomes 1. We just keep adding. Here we had plus 1. Here we had plus 1 to the answer. So basically if you maintain this array is easy, right? Now if we maintain similar array where we do this kind of setup where we have to ignore the even values and put 0 in front of them. And then like we have this array, this is array 1, this is array 2, right? And obviously this will also have its values, some values. Now what I can do here is this. Basically at this place I need this sum, the sum till here. So we make a prefix sum out of this, which will be array 3. This is special actually. This is special prefix sum where we have to ignore things. But this will be a good prefix sum. Make sense? One more prefix sum which we can do is now the number is odd. The number is odd. 6, 6, 7, 8. The number is odd. We have to do this order even will not change its status. Now this is 1. Let's say this is 1. Since it is odd in the right. This will be like zeros, zeros, because of the years. Zeros, ones, 0, 1, 0. Right? This is 0. 1, 1. I'm making a prefix of 1, 1. 0, 0, 1. For this odd guy, this is the basically same arrow as well. For this guy, this is a good count, to be honest. This will also count, this will also count, this will also count. For this guy, the count will start from right here. Now here, the count will be adding up. So I thought like in this case, the sum will be from here till here. Itself, we have to compare here behind. Makes sense because this even is actually nothing if we have odd leader. So for both the cases, the answer is kind of same. Got it. So now I think I'm done with the approach. I'll just test it over this array, which we have been given 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. I will use some example code. Let's just back 1, 2, 3, 4, 5, 6, 7. What I have to do, we have to make an array, which means we're just simply storing the parity. This is odd. So 1, this is even, so 0. This is 0. Right, so this is array 1. Now we make the prefix sum out of it, which is 1, 1, 2. Since it's a 2, we'll change it to 0. Then it's 0, 1, 1. Now, let's come. Here comes the evaluation thing. For this one, we will just count the number of ones from here to here. 1, 2, 3, 4. For this 2, we count the guys from here to here. Here is where I notice a problem because this computation for 3 we have to compute in this region. Right, we need the sum of these guys. These guys when converted to a prefixed array. Like this has to be first converted to this. Which is basically 1, 1, 0, 0, 1. Then the sum of this. For 2 it will actually turn out to be 3. For 3 it will be definitely 3, right? So you see, like, that's the problem. That's the problem. The approach is good. I need to know like what is the parity of numbers. For this segment, the computations which are part of will code this should not interfere at all. How can they interfere? They change ones to zeros. They have done here. They haven't. No, and then after that it is kind of same, right? So whatever sum we get, so saying this was one, it affected this guy, only one guy, for sure. So this is still valid, this part is still valid. So what we can do is basically we can just, since it is up to, we are removing this region. Yeah, this will get affected. Whatever answer comes, we have to add plus 1 to it. So let's say here we add this, it comes out to be 2 or 3 if we do it. So for 3 also the answer comes out to be 2. So we have to make it 3. 3 itself is one answer. Then 3 to 4 is one answer. For 4 we do computation in this one. Again, it is coming out to be, but the sum till this part is actually, which is correct. Now, I'll show you how I come with this. So let's take big example 3, 4. What I want to do is I'm going to convert this to ones and zeros. Right now I make the array to 1, 1, this is 2, 0, 0, 1, 1, this is 3, this is 1, 1, 0. This is the array. For this one line, I just count the number. It's just 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Just 7 for this. For 2, it will be in this region. But I should know that how many odds we had previously. Because for 2, situation has been changed. We should actually apply the logic in this portion and then take the count. But because of the overhead sum, which is 1 at this place, right? This is going to be carried forwarded. It nullified this guy, the very first guy, the very first one it nullified. It made it 0, right? So because of this, we have to, whatever the answer is, we have to add +1 to that. 1, 2, 3, 4, 5. 5 plus 5 is 6. For 3, we have to consider the same thing. We see before 3, so this part was actually 1. So it got compromised. So we have to make it 6 as well. For 4, then we come here, we see it's 0 only. So for 4, we don't need any kind of password. This is perfectly fine. There is 1, 2, 3, 4. For 5, it's 5. For 6, it is opposite. Maybe this was 1. So it is 1, 2, 3, 4. Oh, sorry, for 6, we will start with this guy. With 1. So it has nullified some values. If it is 1, 2, 3, 1, we can come up with a solution. So I have very good feeling that this will work because you know what? Because of these things, like because of the array, the way I write this array, the previous values which are directly early, let's say some number of ones are there, right? And then we make a prefix sum like this, and then we have to take sections, some of these sections, right? Some of these sections, so that we can easily do in order one time using the prefix sum of this array. This array 2, this is array 1, 2, right? For even folks, we know that this is the even line. Starts with this, so they are redundant, kind of. If I include them, yeah, if it is 1, we need to add, we need to actually add, if it is 1, what we used to check for 6, like in this region, if 6 itself is 1, we need to add 1 to it. Just in spite of that, what we can do is basically we can take this entire and say, okay, it's fine if it is 1 way. Because when we apply things to this array, no 1, 1, then it is again 0, this is again 1. This is again 0, this is 1. So you see it will be 1, 2, 3 only. And here it is 1, 2, 1, also 1, this is 0, this is 0, this is 1. So it is 1, 2, 3, 4, and here also 0. So in my opinion, basically if you have to, in case where 6 was 1, what we used to do for 6 now is basically we used to focus in this region and then we add 1 depending on what is the value at this place. But what I'm saying is that if there was 1, we had to add 1. So why don't we take the entire array of 6? And if it is 1, it is well and good. If it is 0, then obviously we have to go with this one. Right? So this is the entire structure, and then we have to basically code it up. So this is the p-sum. We create a p-sum of this array, and for each spot, what we need to do for 5 we just take this sum. For 6, we take this sum, and likewise we just keep adding it. So that way we can solve it in order. So what we have to do is we have to make a, I'll call it like this, AR1, which is, let's write a better name of this. This will call parity array. We restore 0 if even, 1 if odd. Then we have parity sum, where we take a running sum. As soon as we spot even, we make it 0. Same funda here on this guy. And then what we do is basically we actually basically this is the array. So we take this sum, then we have this sum, then we have this sum, we have, yeah, now I think I'm done with the code. Let's move to the coding section and let's tackle this problem efficiently. Okay, let me show you how I can do this. So it is error already, right? So I need an answer which is these at the moment. Cool. So what I need next? Declarations. This is parity. This is, let me put in the same line. This is parity, and this. Then after this, what we get is uh, actually, I'm not laughing, guys, because you might see I'm laughing, but I'm not in a good mood today, but still I'm laughing. Anyways, so this is parity of n, and then we have what next we have? Parity sum, which is n, and then we have another thing which is basically the sum. That looks like that. First thing first, calculate the parity of, and then we can also calculate parity sum and p sum right away. Let me show how I can do it in one minute. Minus values. Do we need n? Yes, we need n. Perfect. What about the answer? Need it? No, for answer we need the feature values. Okay, this is for running values. What I need to do is usually parity as I is equal to I. Mm, That's fine. 0 for even, 1 for odd. Parity of mhm, parity sum of parity sum of I is equals to if I is equals to 0. And that is simply just parity of I as simply parity sum of I plus parity of I minus 1. Since it is sum, you have to be careful. If it is even, it should be turned out to 0. And if it is odd, it should be 1 only. This is for parity sum. Then we have p sum, where we do the same thing but on parity sum. As we do this parity, let's give it p sum. I did a mistake. This is p parity sum. So here we have parity sum. Parity sums I plus p sum. Correct. Now for integer I equals to 0, here what we need to do is basically we have to add the stuff. How can I add it? Basically it's a very simple thing. Answer is how to do this. It is very fun. It's very I return the answer. Here is the answer plus equals to. What we need to add over here is basically what I need to add here. We have to play with p sum. Just the sum till this point, right? Okay, so if I equals to 0, then there's a problem. We just use p sum of n minus 1 minus I. N minus 1 actually. Otherwise, it will be p sum of n minus 1 minus p sum till that point. P sum of I minus n. So I am doing minus, I'm clear on this. And then what we have to do is to, yeah, I forgot to do that. बहुम चलिया तुमसे सनम क्या पर्दा Sorry guys, I'm singing songs today. Okay, anyways, this is the thing, right? And here we are returning the answer, and this is here answer plus. I hope it is correct. Yeah, it is correct, man. I'm sure. Cool. Let's run this up. महफिल में तेरी एरर ना रहे तो गम तो नहीं है. There's an overflow. ओ गम तो नहीं है किससे हमारे नजदीकियों के कम तो नहीं है. This is for 0. Cool. And this is for things which are greater than 0. For n minus 1 at 1, we need something which is at n minus 2, right? So we cannot go till the last index. So we are not going till the last index. Because last index, whatever the value it has, let's say it is just 1. In that case, we need to add 1 over there. For last index as well, we need to handle this because for last index, this is there, correct? And what we will put the minus in here is the n minus 1 minus 1, which is probably n minus 2. It's that your signed integer overflow. Okay, there is an integer overflow. Okay, I got it. First of all, why is the overflow for this small test case? I don't get it. But I'm doing this here. This should be like this. First of all, we added something to the answer, correct? And it is here, right? And then we have the mod. This is the correct syntax, first of all. Earlier it was a bit different. Now we are getting some garbage values. Right, let's go ahead with that. Okay, what is happening here? I equals to 0. We decide this parity thing. So if I equals to 0, it is simply parity of I. Otherwise, it is parity of I plus parity sum I minus 1. Yeah, and then we take the module. Yeah, I'm good with this. And then we have this here where we take the parity sum I sum I minus 1. This is a silly mistake. I think there is more to this. I have to check. This has passed, this has also passed, and this has failed. Okay, let me check. Quickly check this case in my logic now pad. Right, so here we have this one. Check one select is 7. Nice. So what we need to do here is create that thing 1 0 1 0 0. Another guy 1 1 0 0 1 1 0. Another guy 1 2 2 2 3 4 0. For this fog, we got 1 2 3 4. Oh, sorry, this will be 4 only. So for this guy, we got just 4 here. For this guy, 4 minus 1, 3. For this guy, 4 minus 2, 2. For this guy, 4 minus 2. For this guy, 4 minus 2. For this guy, 4 minus 3, 1. For this guy, we got something which is 4 minus 4, 0, which is wrong. Because for this guy, we need to have 1. If I sum it up, I'll get 4, 3, 7 to 9 to 11 to 13, 14. That's what we are getting there. 1, 1, 2, and 1, 2, 3. These 3 guys we are getting. For 5, we get like 1, 1, 2. This is correct. Here also we get only 2 guys. 1, 1. Is it the problem with 14 itself? The answer should be 16, and we are getting something like 14. Oh yeah, so we have loss of two computations. For 2, the answer should be 3, which is coming up to be correct. 1, 1, 2. It is coming out to be like 1, 1, 0. It should be 3, it is correct. For 3, it should be 3 only. No. 3 should be 2 or 2, obviously, I guess. 5, if we work on that, I will get something like 1, 1. So for 3 also we get 3 guys. 3, 3 to 4, and 3 to 7. So for 3 we should get 3 guys. 5 we should get 5 is the first guy. 5 till 6 is the second guy. 5 till third is actually even. Let's see what is well. For this it is 2, it's 5. But for 3 it is miscomputing, right? Serious flaws with the logic which I came up with. Let's go step by step. Right, so this is 0, this is 1, 0, 1, 0, right? So this is the case. For this one, fundamentally, for this one, what we had to do is to basically clear this as 1, 1, which converts to 0. So yeah, for 1 we get this, like here we'll count 1, here we'll count 1, like this. There are 2 odds, right? Here is also 2 odds. Here is for this it is very much fine. The sum of this is the answer, but I agree. Now when we come to this guy for 2, it should be actually modified to this guy. So here we get 0, 1, 1, 0. It should be 3. Because 2 will make 0 with itself. 2 will make 1 with this guy. 2 will make 1 with this guy. This guy, 2 will make 0 with this guy. At the end, 2 will make 1 with this guy. For 2, this is the correct array. So now what happened to this guy? Since it had some payload previously, this one, it was applied to this guy, and it changed the entire nomenclature. Since there was a payload, how did it change? If it is 1, it was 1. Just before 2, if it is 1, it was 1. If it was 1, means it got applied across. This means it changed the first guy which was here. So it made it 1, it made it 0. But it made these two guys 1. Like this. So it is dependent on these number of zeros as well. So what I need here is basically multiple things I need. Yeah, I'm still stuck at the core problem, which is order n square. Because what I assumed earlier was this, because of this one, I was doing that. Okay, I was thinking like it will nullify some of the ones, and then it will be like same if another one comes in. This is true, but the stage of nullification and redemption, like redemption by redemption, I mean that let's say one was effective here, one was effective, but it got normalized from here. This made it this made it one, but it was actually zero. This was zero, right? After this, it became same as this guy. Stays. Now, if you want to have this with one, we had this big array, right? With one, we had this big array. Now, what changes if we remove one? So the parity of one was that, then it will change the parity of the entire structure. If we remove this guy, this will become 1, 1, 1, 1, 0, 1. This one. If a 1 is removed, then we had calculated this on that. So what we had to do is basically this one will affect this guy. This one will affect this guy as well. To make it 0. But in actual scenario, it will start at 0, 1, but it is 0 now. This is 1, 3. It will affect this one as well until it gets omega 1. So this value will affect uh, First one, it will get 0, but that one has its own value. So I think this we have to find which of the folks. So yeah, I think we are in a trouble state at the moment. Solve it. But let's see how we can do it, man. Now another way. We have this count. 1, 2, 3, 4, 5, 6, 7. This is 0. Parity by this is 1, 0, 1, 0. Correct? This is 1, 0, 1. Now what I need here is this. Sum it up. So for one, we are good. Let me have that kind of approach. Right? What is the answer for one? It is the the count is 1. This is invalid pair because the count is right. And this is again a good pair. This is again a invalid pair. So this is like 2, 2. That's what we were working on. Right. For this 2, yeah, here it is 1, 0, 1, 0, but it will be like 1, 0, 0, something like that. So this is clearly not the way we can solve it. If I use something like running, the sum should be odd, right? I think um, it is, guys, it is cadence of all the, how can I forget? It is cadence because, see here, if you start with this, this is odd. We'll add it once again. From here, and the sum should be odd. Sum should be odd, right? So the sum is odd here. Okay, so let me think about it. I think we're live and people are not seeing it. So it's really my playground. Think about I think we are live. People are not seeing what else. This is 1, this is 3, this is 9, 6, this is right. The number of times it was odd, that it will good, great. So for 1 we are carrying it back on. Right. It was contributing an odd number, which is 1. Now if you come at 2, 2 itself is even. Before this is 1 odd number. And its index maybe this will again go against back. Where am I stuck on? One, two, three, four, five, six, seven. What is it hinting to me? 1 plus 2 plus 3 plus 4. There's a pattern. Seriously, there's a pattern. This is 1, 0, 1, 0, 1, 0, 1. Right? It will be like this only. Which are consecutive and linked. Since it is a top, can be put recursively. Yes, now I think I find some common thing. What is that? Basically, TP away probably is that so from this region. The answer is the number of safaris which are apart. No, I cannot solve this that way recursively because whatever answer we get from that part, let's say you got 10 arrays, and there's a one who wants to come in, but because of its index, wherever it is, we cannot let it in. But we know this thing. This guy has all the computation style if it wants to expand. Right, you can also expand this way. Expansion of 7 will incorporate the expansion of 6. Both of them are same. Answer for 7 till here and answer from 6 till here is same. Now there comes 5. The answer from 7 till here is not same actually. There's a difference. It's just the answer from 7 till here incorporates this 5 as well. From here till here, the answer from here till here, and if you include the 6 to it, it will be same. The answer from here to here, if you include some even guy, it will be same. So what I'm saying is 1, 2, 3, 4, 5, 6, 7. From here to here we get an answer. Easily we get it. And then we, if we wish to get answer from here to here, same for this way. Guys go into the compositions. Even the computation is known for the art computation. How many hours is it? इवन के बाद वही बना था फोर्थ का क्या हमने सिक्स का कंप्यूट किया हमने इनका जो आएगा इनका जो आएगा वो सेम आएगा they themselves have no things their answer depends on this region so that's the thing for sure so what we do essentially is the number of chords evens we just repeat that for odds how does it work like for how many gap is there gaps matter for odds for odds gaps matter So there can be like, now if you're talking about odds, right? For this odd, let's make it easy. Is 2, 5, 4, and 7. For this odd, this is the first odd. This 2 will be an answer. I'm putting down the 1 and this this odd will modify it, make it the math. This odd, we will add this 4 value here. This right from this point, so first to that, we add 4 plus 1 here. Invalid. And here we get plus 1. So you see this is an alternate addition. Now for this guy, it is like this 5 is a cold one, but obviously 1 plus 5 there. So this 5 is a cold one, but 5 and then 7. That is it. Right, because in these regions it will be 1. I think now I have cracked the code. So what is the case for this 4? अभी भी प्रॉब्लम है भाई, अभी भी प्रॉब्लम है भाई. This is the 5 one part. This code was sorted. For this guy, we need the sums of, no problem नहीं है, अब सब sorted. Okay, let me show you how it is sorted. For the same example, this is an odd. For this guy, the answer will be, that is the first one at the list. Yes, the answer will be this value and this one. So basically, there is two things here. I can show you. No, do not add this one at this moment. So here we are getting two things. First thing first, this is one. I have to change the color. So for this type, this and this is valid. So it will be plus 1, and plus 1, plus 1, which makes it 4. Copy this to this guy. For this guy, it will be just 1, plus 1, plus 1, plus 2. This to this guy, 2. For this guy, okay, so there is one more here. This is basically 0. So here I say that, okay, for this, yeah, for this particular thing, we had plus 1, plus 1, plus 1, plus 0, plus 1. Basically, add plus 1 to this, add plus 1 to this. It was actually 3. Copy this to here. For this guy, we have only plus 1. So this is actually plus 1, plus 1, 2. And this guy will have only this 0. This one is just 1. 4 3 7 3 just to power the children. Wait. 4 4 8 को 11 दिन 14. तो 16 में apply this. What has happened to this? I think I miscalculated everything. Let me just come back to the original space. only one fork here, one fork here, one guy here. These are the points to make that. This entire region is full mine. So here there is only one event, so it will be, since this itself is an odd, plus one for this, plus one for this, right? This has no use. Now from here, this will be counted. So this is like plus one. After this, there is no region. Right. This is 4 and 4. Yeah, for 3 we have 2. This 1, and then we remove green. This will nullify it. This one. This is 3. For this guy, this will be 2. This guy, same thing. 2. For this guy, only 1. Now what we get? 4 4 8 3 11 14 8 3 11. Wait a minute. I'm giving it fundamentally wrong. Basically, even के बाद podcast नहीं है. Correct. So this is the wrong thing which I'm doing here. I calculated this right. Now I have to do is copy this here. Copy this here. Just like yeah. So for 5 we'll do this. And for this 7 it will be like 2 only. And then the next step will be to populate these values. two even folks. Applying this to this original case. This will be four, 3, 7, 3, 10, 12, 14, 15, 16. Right, I have one more idea here. Instead of this, we can do this. Ending at odd. So for this, what we can do is for this we know that we take the immediate one, which is 2, 1 for itself, actually. Yeah, I have to do like this. This will do max one. So yeah, this will make this guy as accepted one. If I do minus one here, this will make this guy accepted. But this guy is also accepted. Because we get 3 ones. So it's just the sum of these two. These two, it is sum of this guy, which is only 2. Sum of this guy and for this it is basically it is an arm. It is basically 2 minus 1 or limit. And for the next guy, once we know there is a next guy, if there was an explain with some values, it will be accepted, right? So since there's no next guy here, so here 1 for itself, 2 minus 1 for this, and then we have 1 for that. Which I never wanted. Yeah, we just need to add 1, and that depends on the fact. This is not a preferred way. This is the preferred way. This is very clean. But in this, we have to populate backwards, man. That's the issue. Yeah, it's fine. I think we can do that. So if we create these numbers, so they will be like these many numbers. And what are we going to do is 2 to 1 are part of code, and just prove this alone there. This 2 has its 1. So yeah, alternate sum at this location, alternate sum at this location. So I have to create alternate sum, and then what we have to do is to basically use them as we traverse backwards. And if we have some ending values here, which are even, obviously, that will be uh, but again that will be a problem. This there's no master. Also, there's possibility that this will be a trade starts with even numbers. Then it is cool. If some say there's nothing, what will happen is it is 3 with no master, with no master. All these groups have master. Now for 1 why 2 plus 2 is working because So once say this was true, right? And this will be the bonus territory. This is the answer of bonus territory. And then we have these. Let me just. This is very much good problem actually. That is taking me so long to figure it out because my mind is not working today. See, this is how I've created the pairs for this one. If I talk about this one, this is its own directory. The number which it has, it will be right. Then for this one, this directory is doomed. It is not an odd way. This is a profitable directory. Basically, we'll create this array, like this array. Yeah, we will move from that direction. And then what we do is basically calculate answers for each. For this true, for this true answer will be the sum of for this guy, the answer will be sum of this plus this. One, it is one here. This will be three. So we have four. We get three. This guy. We can create that. Right. For each of these there is an answer, right? So we can create that answer using some DP sort of things, and we get like index wise we get the values, and then we iterate backwards. Like since the value of it was 3, it means it had, what did it had? Value of it was 0. 0, I want to say 0. This is like special case, to be honest. For the special cases, we will do that on. So since it has 2, here's this value. There was something there. No, here we got, let's say we got 2. What we do? So since it was 4, it will be assigned here 4. And then there's one more value left. For that we will use this one. Alright, if come here we use the next slide. So for this also we use the, since there's no word spotted, yes, I think I'm now I'm recording it and I'll be finishing this entire thing now. Okay, so what else I need here now? I need to create this map to the vector. Guys, I'm here. Okay. I cannot say anything because someone has broken. But I'm sure you're getting my idea when I write the comments. Since it's an event, we just do this. I have very less time left for this, so I'm just doing it. I think it's fine. It will pass. Okay, except this we get some weird errors. Okay, what is the good some weird access? everyone पे टू हो रहा है basically this is 3 4 5 6 पे टू होगा 6 पे टू हो रहा है राइट एंड यहाँ पे हो जाएगा 1 पे 3 3 6 1 पे टू हो रहा है एंड इस पे हो जाएगा 3 3 3 3 यहाँ पे 4 एंड यहाँ पे 6 yes ST is becoming 6 right ST is becoming 6 here and why is it running for one more time so 1 at first index 2 which is like 3 3 6 fifth index right and then we have 3 at this index there's 3 3 6 3 9 10 10 index पे हमारा होना चाहिए 3 1 यहाँ पे 2 यहाँ पे 3 यहाँ पे 14 पे like it should be 3 3 6 5 पे होना चाहिए 3 और 3 3 6 1 7 पे 96 होना चाहिए सही यहाँ पे होना चाहिए ये 4 which is the 3 3 6 3 9 10 and 11 पे होना चाहिए 5 and 12 पे होना चाहिए 6 but there are 6 elements not How many nodes are there? 1, 2, 3. Six, go ahead, right? We start with 0. We start with this one. For this guy, I have to use real answer. This is the first index answer. I think I missed it. Basically, I was consistent. This is not my fault that the time exceeded because I started too late, man. Yes, of it. Little thing I had. It took me 8 minutes to develop.